Imagine walking through a dusty junkyard in California. Late afternoon sun cutting through rows of abandoned cars, metal creaking in the wind, the smell of oil hanging heavy in the air. Most people would see scrap, but one teenager saw something else. A hidden advantage, a loophole no one had noticed, and what he did next would embarrass some of the most experienced automotive engineers in America, shake the underground racing scene, and prove that raw creativity could beat millions of dollars in research. All for less money than a night out. But here's the real question. How does a broke 16-year-old accidentally discover an engine combination that outperforms factory-built performance machines? Before we dive in, think about this. What if the fastest car on the street wasn't built in a high-end shop, but pieced together from junkyard leftovers? If that idea sparks your curiosity, stick with this story, because it only gets more unbelievable from here. And while you're watching, ask yourself, could something this simple really outperform professional engineering? Late 1960s, Southern California. This wasn't just a place, it was the heartbeat of American car culture. Street racing wasn't hidden, it was alive. Boulevards turned into battlegrounds after dark. Engines roared, tires screamed, and reputations were built or destroyed in seconds. And in the middle of all this, there was a kid. Not a famous racer, not a trained engineer, just a teenager with grease permanently embedded in his hands. While others his age were focused on school, friends, and weekend plans, he was buried inside engines, learning, experimenting, obsessing. By the time most people were figuring out how to drive, he already knew how to rebuild engines from the ground up. But there was one problem. He didn't have money, and in the world of performance cars, money usually decided who won. So what do you do when you can't afford the best parts? You start looking at things differently. To understand what happened next, you need to understand the landscape. At the time, small block V8 engines were everywhere. Two of the most popular variants, the 327 and the newer 350. On paper, they looked similar. Same general design, same architecture, but they weren't treated the same. Each engine had its own correct parts, its own identity, its own rules. And in the automotive world, those rules weren't questioned. You didn't mix components from different engines. You didn't experiment with factory designs. You followed the blueprint, or you risked failure. But here's something almost no one paid attention to. A tiny detail hidden deep inside the engine. Combustion chamber size. And that detail would change everything. One afternoon, standing in a wrecking yard surrounded by broken cars, the teenager was searching for something simple. Cylinder heads. Nothing fancy, just something he could afford. Then he saw them. Old heads from a 327 engine, dirty, neglected, practically worthless in the eyes of most builders. They were cheap, almost suspiciously cheap. And that's when the idea formed, not a fully calculated plan. More like a question. What happens if I try this? Because technically, they would fit. Same bolt pattern, same general layout. No obvious reason they wouldn't work. But here's the catch. No one was doing it. And when something isn't done in a field full of experts, there's usually a reason, or at least that's what people believe. So now the real question becomes, was this a hidden opportunity or a mistake waiting to destroy an engine? Back at the shop, the process began. No expensive tools, no advanced equipment, just cleaning, measuring, thinking. Piece by piece, the engine came together. And as everything was assembled, something became clear. This wasn't just a random swap. It was creating something entirely different, something more aggressive, more intense, more dangerous. Because when you combine certain parts, you don't just change performance. You change the entire behavior of the engine. Pressure builds differently, heat rises faster, tolerance for error shrinks, and if something goes wrong, it doesn't fail quietly, it destroys itself. So, as the final bolts were tightened, one thought lingered. Would this engine even survive its first start? The key turns. The engine cranks. For a brief second, nothing. Then, ignition. The engine roars to life. But something feels different. The sound is sharper, more aggressive, like it's under tension. Even at idle, it doesn't behave like a normal engine. It pulses. It shakes. It demands attention. And that's when it becomes clear. This isn't just working. It's doing something unusual. But sounding different is one thing. Performing differently is another. And there was only one way to find out. There were no test labs, no dyno charts at first, no controlled environment, just streets, real roads, real competitors. Real consequences. This is where reputations were made and lost. So when the car finally rolled out, it wasn't just another build. It was a gamble, because if this experiment failed, it wouldn't just be disappointing, it would be humiliating. But if it worked, it could change everything. The first opponent wasn't inexperienced. This was someone running a properly built performance engine. Expensive parts, proven setup, the kind of car you expect to win. And as both cars lined up, no one expected what was about to happen. The signal comes. Acceleration hits instantly. And within seconds, something feels off. Not in a bad way, in a shocking way. The car pulls harder than expected, stronger, faster. By the time the race ends, it's not even close. And suddenly, confusion spreads. Because what just happened wasn't supposed to happen. Word travels fast in racing circles, especially when something doesn't make sense. People start asking questions, looking for explanations, trying to figure out the trick. Was it hidden modifications, illegal parts, something nobody else had access to? Because the idea that a simple, cheap setup could outperform expensive builds didn't sit right with people. But then came the moment that changed everything. The hood opens, and what's underneath looks almost ordinary. Too ordinary. And that's when the disbelief turns into something else. Curiosity, then concern, then realization. What if the entire system people trusted wasn't optimized at all? When word spreads about a budget engine outperforming professional builds, the reactions are predictable. Engine builders laughed. Experienced racers dismissed it. Even mechanics assumed there had to be hidden modifications. Because the alternative was uncomfortable, it would mean everything they believed about engine building might not be complete. So people started investigating, not to believe it, but to prove it wrong. That's where things got interesting. When the hood was opened and the engine examined closely, expectations collapsed. No exotic parts, no hidden systems, no advanced machining. Just a simple combination of factory components that were never meant to be used together. And yet, it worked. Not just worked, performed beyond expectations. That raised a deeper question. How could something so ordinary create something so powerful? To answer that, you have to go inside the engine itself. Most people think power comes from size, bigger engine, bigger horsepower. But this combination proved something different. Power wasn't just about size, it was about efficiency inside the cylinder. When the air-fuel mixture compresses, the space it's squeezed into changes everything. Smaller, optimized spaces create more violent combustion events, more controlled explosions, stronger downward force on pistons. And that force becomes torque. But there's another layer most people overlook: heat control and turbulence. When combustion happens correctly, air and fuel mix more evenly, burn faster, and produce more usable energy. This combination accidentally improved all of that at once, not by design, by mismatch. And that's what made it so powerful. Engine builders eventually realized something critical. Two parts that were never designed together can sometimes complement each other better than factory pairings. In this case, one set of components improved compression behavior. The other improved airflow efficiency. Individually, they were average. Together, they created balance, a rare situation where airflow improved, compression increased, combustion became more efficient, and throttle response sharpened dramatically. But there was a risk. Higher compression also meant higher stress, more heat, less margin for error, which meant one thing: this engine wasn't forgiving, it was precise. And precision is what most street builds lacked at the time. Once racers understood the combination wasn't a myth, Everything changed. Garages across Southern California started experimenting. Old engines were pulled apart. Junkyards were picked clean. People weren't just building engines anymore. They were hunting for specific parts like treasure. And suddenly, something unusual happened. Parts that were once ignored became valuable overnight. Engines that were considered basic became foundation material for high-performance builds. And the street racing scene shifted, not toward expensive engineering, but toward smarter combinations. Racers who had invested thousands in polished setups began noticing something uncomfortable. They were losing, not to professional teams, not to factory-backed builds, but to garage-built cars with mixed components. At first, they blamed drivers, then tuning, then fuel. But eventually, they had to face the truth. The advantage wasn't in spending more, it was in understanding more. And that realization changed everything, because now knowledge mattered more than money. Engine experts later broke down what was happening in detail. 1. Compression efficiency increased. The air-fuel mixture was being squeezed more tightly before ignition, increasing energy output per cycle. 2. Better airflow behavior. The intake and combustion geometry improved how air moved through the engine at mid-range and high RPMs. Stronger combustion turbulence mixing inside the cylinder became more aggressive, leading to faster, cleaner burns. 4. Improved throttle response. The engine reacted faster to input, making acceleration feel immediate. 5. Higher effective power output. Even without increasing displacement, usable horsepower increased significantly. But here's the key insight. None of this was planned. It was discovered, and that made it even more powerful in the long run. Eventually, the trend became impossible to ignore. Engine builders, aftermarket companies, and even performance engineers began studying the combination. Because if enthusiasts could accidentally achieve this level of efficiency, what else were they missing? This wasn't just about one engine anymore. It was about questioning factory assumptions, and that's a dangerous idea for any industry. Because once people realize better combinations exist outside official designs, they stop following instructions blindly. Over time, the impact went beyond street racing. It changed how builders approached engines entirely. Instead of treating factory setups as fixed rules, people began experimenting, mixing components, testing combinations, challenging assumptions. And that mindset shift became more important than the engine itself, because it unlocked something bigger: innovation without permission. Even decades later, the influence of this discovery can still be seen. Modern performance engines rely heavily on principles that align with what was accidentally discovered: controlled compression, efficient combustion chamber design, optimized airflow geometry, balanced thermal management. The technology evolved, but the logic stayed the same. And that's what makes this story timeless. It's not just about horsepower, it's about perspective. So when you strip away the racing, the noise, the speed, what's left? A simple idea. That innovation doesn't always come from labs or factories. Sometimes it comes from a junkyard. Sometimes it comes from curiosity. And sometimes it comes from someone who simply asks, what happens if I try this instead? Because in the end, the biggest breakthroughs don't always come from those who follow the rules. They come from those who question why the rules exist in the first place. And that leaves us with one final thought. If something this powerful could be discovered by accident in a junkyard, what else is still waiting to be found in plain sight?